Despite everything written, I'm going to talk about wireless LAN architecture. It said meeting customer needs, and I never do that. So let's talk a little bit about architecture. My name is Christopher Jacoboson, by the way, one of the co-founders of a company called Aranya, based in Sweden. I've been working with networks and wireless networks for about 5 years. I'm still quite young, moving my way up.
Event Wi-Fi is another one. Do we want to go to that one? Ward, who runs an actual event Wi-Fi company. So if you're into that one, it's starting right now too. So just wanted to give you an option. Sorry, I didn't want to take people away from
It's all right. It's all right.
I'm trying to load balance a little bit here.
Now they know what it's about, wireless LAN architectures.
Yeah, now they're all going to go away. So.
Yeah, exactly.
Sorry.
All right, yeah, we're going to talk about wireless LAN architecture. It's a stupid picture. I was just you don't have to take notes because these slides will be available. Well, you can, of course, if you want. I'll start off by talking a little bit about wireless LAN history. Where did we start? How did it look before? How did we manage things? How did we deploy? And then I'll go into explaining the 3 working planes of wireless LAN. I'll be referring to them for the rest of the presentation. When talking centralized architectures, pros and cons, distributed architecture, pros and cons. I'm not going to try to say which is best, as many have said before, Gregor and everyone. There's no single question to what type of architecture to use, but rather being aware of what makes an architecture good in each circumstance. And I'll sum up with the summary and a little talk on redundancy. So where did we begin? Who recognizes these guys? That one's been up on a few slides. Internet, yeah. Fat or thick or autonomous access points. Call them what you want. We mostly call them rogues now, as Rick said. It was always a secondary access method. There was this wired infrastructure that was well managed, well planned, and this was the option, maybe designed for a specific little need. So if there was a guest conference hall or wherever you would want Wi-Fi in there, and the IT department put one up just for convenience, just because they wanted to use Wi-Fi as well. This meant limited coverage. You had your IT department AP, and then you run away for a meeting or trying to help a user, and that coverage weren't there anymore. Then you have to roam to the guest one or none Wi-Fi at all. We had little or no visibility with this architecture. You would have to log into that AP to see who's connected, or couldn't pull reports and stuff like that. And it was basically a management nightmare. Especially if you want to deploy more of these autonomous, you put them everywhere. 50 APs, then it becomes really hard if you're managing them individually. So the 3 working planes of a wireless LAN, when we talk about architecture, we slice up the functionality, usually in three different working planes. So there's the data plane. This contains only the actual data forwarding. We have the management plane, which contains the configuration of the units and the firmware management, and also this is where monitoring and reporting comes. And there's the control plane, which got all the fun feature like dynamic radio control, mobility, roaming, load balancing, encryption, decryption, QoS, data filtering. So this is probably my most boring slide, but I'll be referring to these data planes when we're using the real world or made up scenarios later, where I place them on different locations. So this is a company called Awesome Company. There's this guy who's set up 4 autonomous access points. They all got their management plane, control plane, data plane individually, and he made a little configuration error on one of them. Even if it's the SSID, if it's encryption types, you can easily make mistakes, and that's terrible. I mean, you can't roam to that one. If it's a security mismatch, network's not going to work very well. And if If you expand this type of architecture to several APs, like 50 or 100, this is not going to work. So wireless network management systems came into play. They wanted to offload that management plane, want to make changes on one single location for it to propagate to all the access points. So by centralizing the management plane, this became feasible. You could know that all your access points were configured correctly, or if it wasn't, you could get a little tick box saying you got a mismatch somewhere. You're gonna have to fix it. So what else can we centralize? This is a little made-up scenario. Yeah, baby, in corporate. They got a wireless LAN project, 500 employees. They're calculating 2 devices per person. 7-floor building. I made a very, very easy sketch about how their network looks like. They got their internet-facing firewall, core distribution switches where their server VLAN goes. They got their Active Directory there, their DNS, DHCP, radio services, and they got all their access switches with their wired client VLANs. So moving in here, I wouldn't want to have to go and configure all trunk ports to APs. That would be just manually labor intensive. We'll need new VLANs for the wireless clients, I'd say. So by moving in with a centralized architecture here, we could just place a central controller with central data forwarding, central control plane, and a central management plane, and just place the access points out on the access switches. No configuration needed on those switches. You'll just tunnel everything to the controller and centralized. It's very convenient. What's the pros of this? It's easy. It's like new VLANs will only exist between the controller and the core and distribution switches, or wherever you terminate those VLANs. You've got seamless roaming across all floors. So what if this customer has one wired subnet for each floor and you would have terminated the wireless client on those VLANs? If you would roam to another floor, you would have a new IP address and start all over again if you had a session running. Centralized channel and power dynamics. It would be good to cooperate if you have a 7-floor building so they can centrally choose the best power levels and channels. We got end-to-end encryption. One Radius client, so the Radius server configuration will be much easier than if all APs would have asked their own Radius questions. And this gives us one point of management. It's another little made-up project. These guys near you, they are 20 offices spread out over the country. All internet and server access goes through their headquarters. I was trying using Netherlands cities here, Utrecht, I don't know how to pronounce it, but there's 3 cities on here using an MPLS, and they all want to go to their central resources. That's where they need to go. If there is like an outage on their MPLS line or their router, they can't go anywhere. They don't have any local resources. So this is also a place where a centralized architecture would fit very well. This customer might only have IT staff up in Amsterdam, and they could manage those VLANs. They could have separate groups for each city, wherever they want to deploy it, but it will be very easy managing just one central controller in this case. I have a customer who, they're a municipality, so they're using like this type of setup where they have 2 large central controllers and they have all their schools all tunneling traffic to their central site. So if one school just grows a little bit, they'll add another VLAN just inside of their headquarters, very easily fixed. Client traffic is encrypted all the way to headquarters. It's end-to-end encryption. You got the same type of one radius client deployment, easy, and one point of management. So what's the drawbacks of a centralized architecture? It's dependent on those controllers. So you got a single point of failure if you only have one controller. Of course, you should use redundancy, but it's anyway dependent on the controllers to work. We got possible traffic U-turns and bottlenecks. So in this case, if you would have deployed an all centralized data forwarding, and suddenly Maastricht decides to put up their own file server down there, traffic would tunnel all the way to Amsterdam just to go back to that file server, and the response would be all the way to Amsterdam again into the tunnel. So you have to think about what the traffic patterns will be for each customer when choosing architectures. Bottlenecks, someone was talking about it before, and with 11N and especially 11AC, we're thinking about the maximum throughput you can get from that many APs. If you have a big building or something with 100 APs, suddenly if you're tunneling everything to the controller, you must size that uplink correct, so you're not doing like a 1 gigabit there and then you're expecting 10 gigabits on your aggregation. I'm putting scalability issues here, just because it being limited to a hardware platform. I don't know all the vendor implementation. I work mostly with Aruba networks, but so if I'm putting up a controller at a customer or a redundant set of controllers, and suddenly they want to grow just beyond that hardware limit, I would see that as a drawback of a centralized architecture or a controller-based architecture. And of course, they cost money. Controllers and licenses cost money, so I would say a centralized architecture is more expensive than a distributed one. Here I've put up another made-up scenario. Almost looked at like the other one, but in this case they got local internet access and local servers. 4 offices globally demands local survivability, so they will have their authentication servers, their DHCP, their application servers running locally. So we wouldn't want to tunnel everything somewhere here, because if that site goes down or that controller breaks down, they're not going to be able to go locally. This is where I would go with a distributed architecture instead. So I bet many vendors have different implementations of the distributed architecture, but I can just talk a little bit how the Aruba Networks implementation works. Basically, they form a cluster. The access points form a cluster on the same subnet, so they will have a shared control plane, and each access point will forward its own traffic. So all traffic will be forwarded locally in this case, and radius questions will be asked locally, and they will share the control plane for roaming and radio dynamics. And actually this WNMS comes back into play, since if you just pop the controller-less architecture straight out of the box, you'll have to manage each cluster. But if you're a company with this guy got 4 offices, but if you're 10 offices or 20 offices, you need somewhere to somehow you can centrally manage all those clusters. Also, a controller-less architecture is redundant by design, because if you have 10 APs out there forming a cluster and share a control plane, if one of them goes down, the one holding like the master functionality, you'll just roam, that functionality will go to another AP, and the cluster will continue. You will have a little coverage gap maybe, but that's it. Please feel free if you have any other vendor you want to tell, like this is how X vendor solves it, or So this is our company. We also have a use case. We're trying to sell wireless LAN as a service. So we would love to have a price tag on one AP. And by having like a controller-based model, it's hard to calculate, because one customer might want to use us for 2 of their offices, and then they maybe want to expand to their school, but they don't know now. And when they do the school, maybe they want to have 1 school or 3 schools. So it's hard for us to size how we're going to deploy the controllers. So we're moving in with a distributed architecture instead. So customer A could just fill up with how many sites they want, because we are centralizing the management plane into our data center, where we manage their configurations, their firmware. We can pull reports, but the control plane and data plane will be local to each site. So if customer A here wants to deploy 4 new sites, we can just add them up. We don't have to scale up any controller or central limitation. So are there drawbacks to distributed architecture? Definitely. There's a lot of more wired side management. And what I mean by that, I mean, if you're going to have local data forwarding, you might have several VLANs where your clients are going to go. You might have, you will have to configure trunk ports, have all the correct VLANs out to the access port that goes to the APs themselves. There's going to be more radius clients. In Aruba's case, you can configure each cluster to ask the radius questions, or you can have each AP to ask the radius questions. So depending on what radius server you've got there, you can maybe configure a scope that can ask questions, or you're going to have lots and lots of radius clients. It doesn't have the end-to-end encryption. Maybe some hybrid implementations have, but otherwise the encryption ends at the AP and goes onto the wire. Changing architectures can sometimes require hardware replacement. I put that because I bet many vendors are doing it differently. There's hybrid implementations of both of these. Many can do like, okay, you can have it centralized with a controller and then configure it this way, and it will go locally. But I know for Aruba, you can have but they call it instant. So that's their controller-less architecture, and you can convert that into centralized later if you want to switch architectures. I never make the same mistake twice. I strive for 5 or 6 times, this old man says. So this is a little slide on redundancy considerations. So when we move in and talk about architecture and what type of deployment to use with the customer, we need to ask ourselves, like, where and who are our radius clients? Is it my controller asking the questions? Is it the AP asking the questions? And I put servers on there because, of course, you need more than one radius server, right? Are your server certificates under control? I've seen, that's probably my biggest reason when people call and say the network is all down. No one can get onto the wireless network, but their guest network is working fine. That's a server certificate expire. So many people set up their radio servers, many smaller companies set up the radio server, get that certificate running, and then they forget about it. It's a 2-year something maybe, and after 2 years, it breaks down. They have no idea what it's like. And many people say, okay, that's not the network. My stuff is working fine. I'm sending that radius question over there. But it's your network that's not going to work if you don't have control over the server certificates. So you need to step in a little bit there and ask them, do you have this under control? Also on the back end of the radio server, are you using more than one LDAP server or catalog servers to authenticate your requests, or are you just pointing to one? Depending on what radio service you're using, you need to be make sure you're querying several. Who and where are your DHCP servers and IP helpers? That's also, I've moved into many customers where they say, oh, well, DHCP server for that scope should be the firewall, I think. And then we have our Windows DHCP who does other scopes. So making sure they know where those helpers are they redundant, those helpers? And are the DHCP servers redundant? And who are we using for this wireless network? Always test your redundancy. That's also a thing I've seen a lot when working. They say, yeah, okay, we're redundant. We're fully redundant. So I'm like, okay, can we test that? Can we unplug? No. Don't touch it, don't touch it. So many redundant networks have failed, of course. So always test your redundancy. Make sure it works. Make sure the customer sees you testing it and that it works. Wow, I'll be talking fast. I was very nervous, I'm sorry. Yeah, that's it, what I have. Any questions or comments from other vendors maybe, yeah?
The way I see it, all your deployments are basically relying on a layer 2 network, which makes it easier to deploy if you have to expand, like in more VLANs because you're running out of IP address space or whatever. But a lot of our networks that we build aren't that small. They're big, and they're layer 3 separated and all that stuff, so I'm basically stuck to a controller to get that distributed in a fashionable way, and I'm really eager into looking into those developments like Avaya is doing with Spheres.
Should we get a mic? I'm not going to be able to repeat all that. Yeah. Sorry.
So the basic question is expanding in a layer 3 separated network where all these local switched solutions seem to fail if you don't want to have all these different tunnels running back and forth between APs, where we're still stuck to controllers. Besides the fact that controllers might be expensive, that's arguable. Then again, bandwidth is not a problem in the biggest networks that I've seen wirelessly. And I'm talking really big networks like in 2,000-3,000 APs. No problem whatsoever with regards to bandwidth. But the layer 3 problem is what I see as a problem in the locally switched solutions like Aruba, like a Juniper, like even Cisco has. So I was wondering what your idea about that is, because I haven't seen anything of it being resolved in your presentation.
No.
So don't feel bad about it. It's just
That's good. That's good. Great comment. Having layer 3 separations. Are we talking like a big campus where you have several layer 3 for your
hospitals, big campuses, big networks? Yeah.
I'm not sure really what I'm going to say about that, but sure you can use smaller clusters with layer 3 mobility, where you could, I'm not sure how all the vendors do it, but Aruba you can roam in between the clusters, so you'll have different clusters in maybe different houses of your the hospitals.
I have to be honest, I'm starting out with Aruba with like a few weeks, because it's a new product for us that we're going to run. So I don't know how they scale with regards to tunneling back and forth between clusters. Because the majority of vendors always say, well, a controller-based network isn't scalable because everything needs to go to the controller. And once you address the fact that everything is going to be distributed amongst APs, there are no scalability numbers. Nobody tells me I'm going to tunnel that much traffic to that AP and that much traffic to that AP, so where's my bottleneck? Because if everything's going to a set of APs because the algorithm just chooses that AP, then that's going to be my bottleneck. Plus the switch that's connected to, plus the uplink from that switch to the central core. So loads of stuff. That's just my idea.
Yeah, okay. You want to comment on that? Sure. All right, thanks. Cool.
Okay, so I'm really opinionated on this topic. So I will not go into too much of depth. So if you want to discuss specific architectures, feel free to grab me, but there's ways to spend several thousands upon thousands with distributed, right? I would just add on, so I'm not touching either, right, for vendor wireless stuff, but I would just add on whatever you choose, and once you've designed it correctly, don't forget about network management system. Right? Controller or controllerless, with the controllerless usually having the benefits of packaging it together as it is. But it's the network management system that provides more than just a point of pushing configs or point of whatever, because it retains much more historical data in comparing just to your layer 2 devices that a controller or whatever alternative is. So just remember, whatever you do, NMS is important.
I got way more minutes if you want to add something else to the presentation.
It was a good presentation.
Okay, thanks.
Yeah, yeah.
Any other comments, questions? Okay, early lunch then, I guess. Thank you.
Okay.